Hello, this is Scholar Strive doing some math today in Algebra 2. We'll be looking at geometric sequences in series. So in an arithmetic sequence in series, we found the difference to be constant between terms. Like we're adding 3 or we're subtracting 3. In a geometric sequence, there's a constant ratio. So the ratio of consecutive terms is constant, and the next term is found by multiplying the previous term by a constant. And we call that constant R, the common ratio. So let's look at this example here. 1, -4, 16, -64, 56. When we multiply by -4 each time. -4 times -4 is positive 16. 16 times -4 is -64. So this one, our R value would be -4. So let's do this example here. Determine whether the sequence is geometric, arithmetic, or neither. Okay. So obviously part A, it's not arithmetic because the difference between the first two terms is not the same as the last two terms. So let's see what's going on here. 128 is 1/4 of 512. 64 is 1/2. So this is neither, because this is going to be 1/8. You can see a pattern going on there. Multiply by 1/4 and 1/2. And actually, no, it's not a pattern. It's neither. Okay, let's take a look at this one. So here, we kind of just, let's ignore the denominator because they're all the same. If we look at the numerator, we multiply that by 3, and then we multiplied it by 3 again, and 3, just multiplying by 3. So this is geometric. Each term is multiplied by 3. Okay, part C. If I look at the difference here, this is plus 10, so this is arithmetic. D equals 10 here, R equals 3 here. Okay, and then we have a rule for anything that's geometric. This guy. First term times R to the n-1. Alright, and again, memorize. Okay, just a reminder, the arithmetic one is A, the first term, plus n-1 times D. Geometric is this one. So write a rule for the nth term of the sequence with the given information, then find base of 10. So what's going on here is that each one is being multiplied by a third. Okay, we're basically dividing by -3 each time. So that's the same thing as multiplying by a -3rd. Okay, so I have an R of -1/3. Okay, our first term is 972, so we can write our formula. Base of n is 972 times R, first -1/3 to the n-1. There's our rule. Okay, and then we want to find the 10th term. So 972 times negative 1/3 to the 10 minus 1, so the 9th power. So use our calculator here, and we'll get negative 4 over 81. Okay, part B. Okay, they tell us that the 5th term is negative 18, and the common ratio is 3. Okay, so we have a sub n equals a1 times r to the n minus 1. So a sub 5 is a sub 1 times 3 to the 5 minus 1. A sub 5, they told us to be negative 18. And 3 to the 4th power is 81. Divide both sides by 81, and we'll get a1 equals negative 18 over 81, which reduces to negative 2 over 9. Okay, now that we know what that is, we can write our rule. A sub n equals negative 2 over, or a1, yeah, negative 2 over 9, times r, which is 3, to the n minus 1. If we were going to graph this, it would be exponential, and it would look something like that. Okay, part C. Okay, this time they gave us 2 different ones. So they have a sub 2 is 10. Is a1 times r to the n minus 1. So they have 10 equals a1 r to the 2 minus 1, so r to the first. Okay, that's one equation. And let's look at our other equation. A sub 7 is equal to a1 times r to the 7 minus 1. So this is negative 320 equals a1 r to the 6. So what are we going to do here? What we can do is use substitution. Because I can solve for a1 in this one by dividing both sides by r. So I have 10 divided by r. So I'm going to plug this in to the blue equation. There. Right there. So I have negative 310 equals 10 over r times r to the 6th. So that'll give me negative 310 equals 10 r to the 5th. Divide by 10. And I'll get negative 31 equals r to the 5th. Oh, 320. This is 320. 320. 320. This is 32. Okay, and then I'm going to take the 5th root of both sides. And that'll give me, hopefully, a nice number, negative 2. R is negative 2. Now that I know what r is, I can finally write my equation by plugging it back into this one. 10 equals a1 times -2. Divide both sides by -2. a1 is -5. So my equation is a sub 1, which is -5, times r, which is -2, to the n minus 1. And there's my rule. A geometric mean is the term between two terms in a geometric sequence. And if you remember from geometry, we had this. So here's a and b are our two terms. Oh. And x is our geometric mean, the number in between them. Alright, so let's try this out. So we're looking at 2 over x equals x over 8,192. That'll give me x squared equals 16,384. Take the square root, and we'll get x equals 128. So the middle between that and that is 128, and then we just do it again. 2 over x equals x over 128. And that'll give me x squared equals 256. Take the square root, and we'll get x equals 16. So what's happening is we're multiplying by 8 each time. So 128 times 8 is 1,024. Now you could always do the geometric mean between 128 and 8,192. That'll get you the same answer, but it's just easier finding the common ratio at this point. A ball is dropped from a height of 8 feet. The ball bounces 80% of its previous height with each bounce. How high to the nearest tenth of a foot does the ball bounce on the 5th foot? Okay. So it starts off, right, dropping from 8 feet, and then we have a first bounce. And we know it's 80%, so we multiply by 0.8, and we'll get 6.4. Then we multiply by 0.8 again, and we'll get 5.12. Multiply by 0.8, 4.096. Fourth bounce, 3.2768, and the 5th bounce, 2.6. And they want to the nearest tenth, so I'm not gonna, well, so this is what you would get in your calculator, and then you would round to 2.6 feet. Or you could have used the formula, r equals 0.8, a1 is 8, and n equals 6. Alright, a geometric series is the sum of terms in a geometric sequence. Okay, the sum of the first n terms of a geometric sequence is this formula. Alright, find the sum of this series. Okay, you need to find the first term. So a sub 1 is equal to 7 times negative 5 to the 1 minus 1, which is 0. So 7 times negative 5 to the 0th power, which is 1, which is 7. So I have a sub 1. And then what else do I need? I need to find out what r is. Okay, r, remember, is this value here. Because this is a1 times r to the n minus 1. I guess I could have gotten a1 from that too. R is negative 5 in this case. And n is this number here, 11. Okay, now we're going to use our formula. S sub n equals a1, which is 7. Okay. Times the quantity 1 minus negative 5 to the 11th. Over 1 minus negative 5. So this is 7 times 1 minus some huge number. Negative 4, 8, 8, 2, 8, 1, 2, 5. Divided by 6. Punch into your calculator at this point. 56,966,147. Alright, what is the first 8 terms of the geometric sequence? 5, 15, 45. So it looks like our first term is 5. We're multiplying each thing by 3. And they want to know the sum of the first 8 terms. So S of n equals a1 times the quantity 1 minus r to the n over 1 minus r. So this equals a sub 1, which is 5, times 1 minus r to the n, so 3 to the 8th, over 1 minus 3. This will give me 5 times the quantity 1 minus 600 for 6,961 over negative 2. So this is 5 times the quantity negative 6,560 divided by 2, which is 5 times 3,280, which is 16,400. This is the sum of the first 8 terms in this sequence. Hopefully this helped you out. Have a good day.